In this lab, we look at calculating density through mass and volume. We record volume and we record mass. Volume we calculate a couple of different ways, and you'll see some different variations based on your measurements, and the way that you measure. We'll use Archimedes' principle or displacement, as well as the traditional length and circumference calculations as well. There is a link to this lab in the description below, and we'll reference that throughout the lab. We're going to use 4 different cylinders. There's a copper, a brass, a glass, and an aluminum cylinder. The first thing that we'll do is take our scale. We're going to add a weigh boat to it so that we don't put anything directly on our scale. Remember to tare it. Then we'll add the first of our cylinders. In this case, it's copper. Make sure to record that in the table. We're going to repeat the process. In this case, we're going to do brass. Notice that I am touching each of these with my fingers and not using tools. So you're going to get some substances on there, like the oils from my hands or any dirt. And so there's going to be some inconsistencies there. We're not having a pure substance. So there's your mass for brass. In this case, we're doing glass. And then finally, we take a look at aluminum. So when you go to write your lab report, consider some potential errors in this or some inconsistencies. So to calculate the volume, we're going to use some geometry. And we'll use this ruler and we'll calculate length and diameter. And you'll use the formula to calculate volume of a cylinder. So you can see here first we have 1.25 centimeters. And then we measure the length. That was the diameter. We measure the length, and notice here I'm starting from the 0 point of the ruler, not the end of the ruler. And this measures 4.00 centimeters. And that was for the copper. Go ahead and repeat the process here. Diameter for the brass is again 1.25 centimeters. And again, I'm starting from the 0 point of the ruler, not the edge of the ruler. And then this guy here measures 4.00 centimeters. Moving on to the glass. This one, you can see it's chipped on that end, so I'm going to use the other end here. Again, it's 1.25 centimeters. My calculation using this method is not going to be super accurate, again, because of those chips. I'm missing some of the volume, so that's something to keep in mind. And then going ahead and measuring out the length, it's 4.25 centimeters here, a little bit longer. And then finally, we're going to measure the aluminum. And again, the aluminum is 1.25 centimeters in diameter. And we are at 5.00 centimeters in length. Another way to measure volume is displacement, or Archimedes' principle, where you take a volume of liquid. In this case, we're using our water in our graduated cylinder. Then we're going to add our irregularly shaped object to it, and it will displace water and provide us a new volume. However much water it displaces, so the difference between the second volume and the first volume, is the volume of the centimeter. Keep in mind that 1 milliliter is equal to 1 cubic centimeter. And so finally, the link to the lab document is in the description below, and then the formulas that you need in order to do these calculations are also located inside of the lab document, as are charts to record this data. As always, thanks for watching.